Yeah, thank you very much. I hope all of you can hear me really well. Is good from sound? I think so, right? Perfect, right. Yeah, like Lisa said, so I will talk a little bit about the term software architecture and how we use it at the moment. I hope also that English is okay for everybody. So I figured out that there are a lot of persons that speak English here on the conference, and that's the reason why I also said, okay, it makes sense to talk here in English right now. So, but first, because P3 for sure, 2 characters, what is behind that one? So we are a technology consulting company. And yeah, we are on the market since more than 25 years with more than 1,800 employees at the moment. And that also around the world. So on the right side, we just listed all the different locations where we have our offices, and we are still growing. Today we got the latest news that we are right now also in Poland with a new subsidiary. So, and also here, that's the important thing. So we are not only a technology company, so technology consulting, we are also really strong in software development. And here we are also in different domains. So automotive, that was our domain where we started, but then also in the energy sector, but also banking, insurance, media, logistics, and I will come also to that back today, and also rail and transportation, but also several others. So our head of HR said once, we are a little bit the playground for persons that want to grow in different kind of experience at the end. So first of all, if you are talking about software and also different technology stacks, what we are using, because that's, I think, also interesting, I would say we are open for everything. We are listening to our customers, what also they would like to have. And also there we are working close together with Microsoft, but also with Amazon and also with Google. And like I said, so we are in different technology stacks and also programming languages active, like the ones which you see on the left side and also in the related frameworks. But let us come right now to the term of software architecture and what does it mean, because here I have a first question for you. So you see here these 4 images right now. And I would like to ask you right now, what would you say is for you software architecture? So let us start with the first one. So who would say that for the first one, that's software architecture at the end of the day? No one. Second one? 1 person, 2 person, 3 persons at least. The third? No one? One, okay. And the last one, who would say this is software architecture? Yeah, 1, 2, 3, 4, 5 hands. This is not software architecture at all. That's the point. So, and that's the thing. So if you look at this definition of software architecture, you will figure out that there are several statements, definition, what is software architecture. And all are related a little bit to the structure, how an IT system at the end of the day is designed, how it stays in collaboration, and what kind of interfaces are used at the end. So the question is right now, okay, how we can find a common definition for that one. And my personal loved definition for this is the following. So it comes up with that one. So software architecture is at the end of the day just the design decisions which we made, and also if they are made incorrectly, where then the project at the end of the day is cancelled. Because the software architecture themselves is just at the end of the day the more or less summarization of all the different decisions that we took in the past to develop this system. On the fact that we are work today in iterations if we are working in a software development project, and that we don't know what comes up in the 3rd phase or the 4th phase or the 5th phase. And here it's then the case that we cannot take at the moment a decision. So we cannot say right now upfront we have the complete software architecture, but at the end of the day or to a specific time we can say, okay, at the moment this is the software architecture for our current system. And we can just look at the status at this moment. And for sure, software architecture is dependent on different things that you can see on the right side, right? So it's related to the processes. So what shall the IT system that you develop or on that you work reflect at the end of the day? So it is in general related to a business, what is behind that one, so the business processes, because this is what you try to automate. but also then at the end of the day, like I said, the structure, the frameworks that you're using, and what are the capabilities of the frameworks, the interfaces, and many more. And for sure, there are also some principles. So, and these principles are related to that what we see often on different homepages and web pages, so that there are, in general, 3 different styles that you can say, or that you can name architecture patterns. The one on the left side is the monolith. And I assume no one really likes to work with a monolith or to develop a monolith. We will see if that's, more or less all the time a bad decision or a good decision. Then we have on the middle the service-oriented, where we have in general an enterprise service bus, which does the orchestration and also the coordination. And on the right side, for sure, that what is, I think, a common pattern for everyone that everybody knows, so microservices. And if you are talking with customers today, you can imagine that in around about 90% of the discussion, if you want to develop a new system, first of all, the term microservices comes in place. So everybody wants to have microservices. But the question is that all the time a good decision? From our perspective, no. The reason for that is really easy, because at the beginning, you want just to develop something where you see if you can automate this in the right way. From the beginning, so from scratch to develop a system, microservices, for example, you will have a lot of communication overhead. You will see also in the future, for sure, there is an approach how you can come from the monolith to a microservices if you want to use that, but never go with that approach to say, okay, microservices is the only solution. That will never work. In general, what do we have to consider if we are, more or less develop then new modern web applications? And I'm just focusing here on web applications because for sure, you have also to focus on that one if you are developing embedded systems, for example. But here we are focusing on web applications. And here we are all the time referring to that what is called the ISO 25010. So, which is the explanation at the end of the day for the categorization of non-functional requirements. And non-functional requirements is a lot of time this was missed in the definition of new IT systems. And especially then if you are discussing with your customer, because the customer says, okay, I want to have that functionality. But a lot of time it's missing the term to say, okay, good, I want, for example, that I get a response for a specific action within 200 milliseconds, or that there should be also a backup if, for example, one instance at the end of the day fail, that another instance will take over that one. So these are things that you have in general to consider. And the ISO themselves, so just divided into this, at the end of the day, 7 different categories, where you then really can focus on that and say, okay, this is what we considered. Here we took that, and at the end of the day, a decision that makes sense for us. And that helps at the end also to create then scenarios. And these scenarios explain exact, okay, how the system will work to the runtime if it comes to different cases, like, for example, that we want to have a response within 200 milliseconds for one specific action. Another point that a lot of time is missed, but that we have to consider if we are talking about modern web applications, is what is used as infrastructure. So a lot of the different companies with them we are working together are missing the part of the infrastructure. So for sure they want to have the IT system, but they are not aware that must it run at the end of the day on a cloud, like for example Azure or also AWS, or shall it run on a private data center? What is regarding data privacy? So these are things what you have to consider, and also here you have to consider who is at the end of the day responsible to run which specific component, and also who is then at the end of the day the responsible person if something will fail, because responsibility is there a hard topic. Let us come to a small case study that I have right now here with me, and that's in the field of energy logistic. And here we started a few months ago together with our one customer. I unfortunately cannot give the name because it's a little bit secure. Where we at the end of the day just had to design, which is responsible at the end to, yeah, more or less give for the end customer some information regarding the orders that will done, so in the logistic domain, and also in special on the Haber ports, so where our customer is active. And also there are some requests at the beginning, and this is in general where you start. So the first one to say, okay, developing of a web portal, which can be used to send and monitor so the different orders. Second point was to say, okay, customer and order have a high fluctuation, which means you have days where there are more or less 10 to 50 orders, but also other days where there are more than 200 orders. And also for that we have to work there with critical infrastructure. So for sure we have to think about failover and disaster recovery at the end. And also what they had as a constraint is that no persons were more available to manage their physical IT infrastructure. So there were no person anymore who could say, okay, if something in a data center will fail, I can fix that. So what we decided here, and here you can see that also then in the correlation with the other systems, so that we had there also the core interface at the end to the terminal management system. So just for the scope, the terminal management system is used on the Haber to do all the processes regarding incoming ships, load, discharge, but also then stored into the different tanks that you have. And we decided at the end that we will go with here a microservice approach from the beginning on. Also, if I said before, okay, it's not good to start with that, but we were considered all the different domains that were in the system or that we want to build up in the system. And also we are using in P3 in general a framework how we orchestrate the communication with that one. Furthermore, based on the fact that there were no persons for the data center management anymore, we also decided to develop that complete on Azure and also used for that the different platform as a service components, because we want to optimize here the effort for the operational part. How we did it at the end, that's just a small diagram. So for each service domain that you saw before, here you can see them again on the left side. We said, okay, for each service domain, we developed for that microservice, or with the microservice approach, so more or less a stream that then just pumps in the data from the left side, which are unsorted from the different terminal management systems that were transformed at the end of the day into the right order, also stored, and can then be on the right side, gathered by the front end and requested by the front end so that you can then see them as a customer. And the conclusion, what we also learned until now, is for sure the identification of the reference architecture. Because that's the point. In general, you not have to start from scratch. If you discuss about an architecture, about a new system architecture, there are on the market some reference architecture that you can use as a blueprint, and from that you can start. The second one, for sure, follow well-known design principles that are existing regarding different use case scenarios that are existing for the specific domain. So if you are in a CRITIS domain, so critical infrastructure, for sure you have to think about failover with hot instances. You have to think about disaster recovery if your system is compromised at the end of the day. And you have to gather also in the beginning the different requirements there from the customer. The third thing, think about software product quality. So the different things of the ISO norm that I mentioned. And last but not least, because this is something that can have a lot of effort. So afterwards, if you not do it well at the beginning, don't forget about the infrastructure. So, thank you very much. And if you want to talk with me about that one, I'm also on the both C12 until 15 o'clock. And thanks for your attention.